So let's dig in. I'm going to spend most of my time in the Chrome console. So I'll just be navigating to a page called about:blank. This is a really nice place if you ever want just like a scratch pad. So in Chrome, you can go to about:blank, and I can open up the Chrome DevTools here. I'm doing that with View, Developer, JavaScript console, using the keyboard shortcut there, but whatever works for you is totally fine. You could do this in Replit, you could do this wherever it may be, but I find myself working a lot in the Chrome DevTools, especially with a bit of a scratch pad for things. So we're going to be talking about asynchronous code, or async. Asynchronous code is the opposite of synchronous code. So you're here to learn about async code. I want to ask the question to the audience. Feel free to throw an answer in chat of what is synchronous code? You might not know about async, and I will gladly teach you that, but what is synchronous code? Yeah, Brian, go for it. You got your hand up. Take it away.
Does that mean everything's going in order?
Yeah.
Like top to bottom?
Yeah, everything is essentially going line by line. And 90% or more of the JavaScript that you write in the browser is synchronous. You can make a variable. My first name is Ellie. My favorite numbers are 1, 2, and 3. I'm going to make a for loop, and I'm going to loop as long as I is less than 10. I'll increment I, and then I'll go ahead and I'll, map over my favorite numbers, and I'll return a new array with each number multiplied by 2. All this runs line by line. Now, under the hood, the JavaScript compiler is going to do some things that are happening behind the scenes that might not feel like they're line by line. That is so abstracted away from you. You can essentially think of these as running line 1, line 2, line 3, line 4. So synchronous meaning just happening in order. Not exactly at the same time. Same time is actually called parallelism. So parallelism is you have 5 things and they're all happening at the same time. They're all happening in parallel. I want you to think of synchronous as you have one timeline, just one single timeline. In computer science, we often call this a thread. You have one timeline of stuff happening, and stuff happens on that timeline at time 1, time 2, time 3, time 4. And that is what synchronous code is. Synchronous code is also called blocking code. So I'm going to go ahead and I'm going to run this code. It's going to happen line by line. It's all going to execute right away because there's nothing that's particularly slow here. But I'm going to write some code that might actually take a while to finish. I'm going to go ahead and I'm going to console.log starting. And then I'm going to console.log ending. And I'll go ahead and run a loop that's going to go for a pretty long time. This loop right here is synchronous code. We will not finish executing this line of code until this line has finished. And what that means is while this loop is happening, I literally can't do anything. I'm trying to do 1 + 1. I'm trying to console.log hi. I'm literally hammering the enter key and nothing is happening. This is called blocking the thread or blocking code. You can think of this like a timeline where time 1 is very fast, time 2 takes a really long time, so nothing else can happen. When you write blocking code, you can't interact with a web page. So if I have a really long for loop that's running, I can't start clicking on buttons and typing in forms or anything. I have to wait until this has finished to even continue executing any JavaScript code that may be on the page. And this is how JavaScript works. In the browser, this is how JavaScript works as a language, as an environment. This is how many programming languages work. Most of the things you write are synchronous. And then there are tools or mechanisms in the language to enable things to not have to be synchronous. Not a dumb question by any means. Tanya asked, how did you get this code to start running in the console? I opened up the Chrome console. I typed this code and I pressed enter. So I went to a page called about:blank. You can go anywhere in Chrome, but about:blank gives you a console with no other things in it. Went to view, developer, JavaScript console. And then I opened it up here. And now look at that. The loop finished running. And here we are. Now I finally see ending. Now I see a bunch of things that I've been trying to print out. Now it's finally working. That's blocking code. It took a while, but we eventually got there. That is what synchronous code looks like. And most of the code you write in JavaScript is synchronous, and that's a good thing because it's easier to manage internally. It's easier to keep in your head. And that's how most JavaScript works. But there are certain things that we can do in JavaScript where instead of blocking, instead of nothing else being able to execute, we can instead do things asynchronously. So synchronous meaning happening on a timeline in order, line by line. Asynchronous meaning happening at different times that are not necessarily guaranteed or predictable. To make a new line in the Chrome console, that's just Shift Enter. So there's a question here of how do I make a new line in the Chrome console? Shift and Enter. There are two common places for writing asynchronous code in JavaScript. There is a built-in function to JavaScript called setTimeout. And setTimeout is a function that accepts a function. We often call this a higher order function. So if you were at our callbacks lecture, this is a classic example of a function that accepts another function. You could pass in an anonymous one, you can make it up on the fly. And setTimeout as its first argument accepts a function to be run. And as its second argument, after a certain amount of time in milliseconds. So this represents 3 seconds or 3,000 milliseconds. And whatever you do in this function will be run after this amount of time. You're never guaranteed that it's exactly 3 seconds. It will be at the very fastest 3 seconds. So I'm going to console.log. Hello. I'm going to console.log. Wonder why that just removed for me, but I'll go bring that again. So I'll console.log starting. I'll console.log ending. But in the middle, I'm going to set a timeout. And I'm going to run a function after 3 seconds that says hello. setTimeout is a built-in method to JavaScript, and by its nature, it is asynchronous. I don't have to do any magic here to tell setTimeout to be asynchronous. setTimeout, as it is written, is naturally asynchronous. If you want to learn more about the mechanism for how asynchronous code works, you can look at something called the event loop. I think it's an interesting thing to study, but when you're first learning about asynchronous code, it's a lot of theory that often gets mixed up with the actual application. So if you're learning about the event queue and the call stack and so on, yes, those are all the underlying tools that power this, but I want to start at 10,000 feet and then we can dig into those more meaty computer sciencey concepts. Console.log is synchronous. So I'm going to run starting. setTimeout is asynchronous. So we are going to run the setTimeout function. And internally, what this tells JavaScript is, hey, JavaScript, I want you to keep running, but do me a favor. In 3,000 milliseconds, go do this thing right here. Otherwise, just move on. So we are going to console.log starting. This function will run, but the code will continue running. We will see ending, and then in approximately 3 seconds later, we're going to see hello. setTimeout is very useful for You want to do something after a period of time. You want to show the user a notification, and then 5 seconds later, you want to hide it. Why would it be very, very, very bad if set timeout was synchronous? Why is set timeout just built into the language? Why is it asynchronous out of the box? From what we saw before, why would it be a very terrible user experience if set timeout was synchronous? Feel free to throw this in chat or raise your hand. But knowing what you know about blocking code, why would it be so unpleasant for a user if every set timeout we did was synchronous? Yeah, well, a lot of things, you have to wait. If you remember with blocking code, when we block with synchronous code, you can't do anything. I'll just demo that again so you can see this in a bit of a real world context. But I'm going to go to Google and I'm going to run that, lovely for loop that I had before. I'm going to say I is less than some gigantic number. And I'm not going to do anything in the loop. I'm just going to run it. And while this loop is running, that was a little too fast. I'm going to crank it up a little bit. I literally can't click on this input. I can't click on this link. Once it finishes running, I can do that. But if I have a very long bit of code that is blocking, I'll make this even longer. I can't do anything on this page. I am blocked. There is nothing that can execute. I'm clicking on this link. I'm trying to type in this form. I'm trying to search on Google. This is synchronous code. This is blocking code. And finally, when it's done being run, I'm in good shape. So if set timeout were to be synchronous, then we would console.log starting. We would then have to sit with our hands very patiently for 3 seconds while nothing can happen. And then we would console.log ending and hello. That would be a very terrible experience for the user. Set timeout is a method that's built into JavaScript. It is inherently asynchronous. This is probably the first thing that you see in general that is asynchronous. And it's asynchronous for a good reason, because you don't want to have to sit there and wait, especially if it's a long period of time. In 5 seconds, go and do something. Let me do things during those 5 seconds and then go ahead and do what I want. So asynchronous code is just this idea of executing some code after a period of time. The more real world use case for asynchronous code is a series of web technologies called Ajax. Has anybody ever heard of Ajax, seen Ajax, used Ajax, cleaned with Ajax? It's not actually the cleaning product, but yes, for those of you that know what Ajax is, give me just in the chat, give me a 1 sentence. What is this thing? And if you're like, Ajax is asynchronous JavaScript, I can actually spell the word JavaScript, that'd be good. And XML, yes, that is the acronym. So I'll save you the acronym, but give me a 1 or 2 sentence thought in chat for what it is, what it does, and so on. I see some thumbs up. I'm expecting some things. A way to use the language to make async happen. No, not exactly. Doesn't really have to do anything with a way to make JavaScript async. Feel free to throw it in the chat. Would love to get some thoughts here, because I'll definitely be looking for some knowledge of this piece. It's not something I expect you to know. So if you come across it, awesome. There's a question here, is there a way to interrupt or stop the synchronous process in the console? No, once it's running, it's blocking. You can, forcibly close your tab in the browser or turn off your JavaScript program, but you can't, once that process is executing, you can't in the middle just be like, just kidding. You have to either kill it and completely terminate it. There isn't really like a gentle pause. All right, so we can use it for a network. It's a way to update a section of a page without reloading a page. That's good stuff. That's what we want to see. Very good. For API calls, excellent. Ajax is a series of web technologies that allow us to make requests to servers in the browser using JavaScript without refreshing the page. When you go to a web page and you click on a link, you make a request to some server and you reload the entire page. When I click on this link, I reload the entire page, click on this link, reload the entire page. For those of you that ever used MapQuest way back in the day, where you had to put in your starting location and your ending location, and when you press enter, it reloaded all the directions in the entire map. And then if you're like, oh, just kidding, I want to go to 561st Street instead of 600, you got to go type in the form, completely reload the page. That's how most web applications used to work before 2000 to 2002. Ajax is the really incredible technology that powers amazing feats of JavaScript like Google Maps. Instead of completely reloading the page, I can go ahead and fetch data from a server without refreshing the entire page. I can drag this map and load new things without refreshing the page. I can go ahead and change the data on this page and set directions without reloading the entire page. This idea of sending data to a server, getting data from a server without having to do a full refresh of the page is what Ajax allows us to do. If you have not made network requests, if you have not worked with APIs before, that's totally fine. I'll show you how to do that. But anytime that you go to any application and you fetch data, you either have to refresh the entire page, or you can use Ajax to make a request to a server in JavaScript and not refresh the page. Many real-world applications use both. I'll show you LinkedIn, for example. If I go look at my network, it's going to completely refresh this page. If I go back to home, it's going to completely reload this entire page. But if I scroll down and I want to load more posts, I kind of want that infinite scroll functionality.
Myths with the Gargi.
It's not going to do a full page refresh. I'm still fetching data. I'm still getting data from some server as I scroll down. When I want to see what my notifications are, yeah, it might do a full page refresh. But if I want to see what my messages are, if I want to send a message to someone, when I send this message, I'm not going to reload the entire page. This is where you find yourself using Ajax as well. When I search, as these results come in, this is being sent to a server and data is being fetched for my search results, but I'm not refreshing the page. That would be a very uncomfortable user experience. That is where Ajax is being used. All Ajax are a bunch of functions in JavaScript. So I'll show you those functions. I'll show you how to do it, but this is where Ajax is being used. So what is Ajax? It's the ability to fetch or send data to a server in the browser, in JavaScript, without refreshing the page. The default behavior, anytime you make a web request, is to refresh the entire page. That works for some applications. It's totally fine. But for others, it's pretty terrible. Like imagine if Google Maps, every time you search something, you have to reload the entire map. That would be way too much work. Brian, I saw your hand went up for a sec. What's up?
Yeah, I think you kind of answered my question, but because with the Google Maps, it was confusing me because every time you do something on Google Maps, you can see the URL change.
Mm-hmm.
So I thought it was reloading the page just very quickly with the new data that you wanted it to show.
Watch this.
But the scrolling thing makes more sense to me.
What? Look at what I just did. You can use JavaScript to change what the URL is. This is a tool called single page applications or client-side routing. So what Google Maps does, and what it did so well, is it gives you the illusion that you are going to all of these different links, but under the hood, it's actually just JavaScript changing that for you. So that actually, it's a great job by Google Maps. They fooled you. This is what kind of that technology is that's powering that. And JavaScript can change the URL based on the action you do. You could then send someone that link and your application will say, cool, I know exactly what to do. So when you send someone a link on Google Maps, it knows from that link what JavaScript to show you and such. This is a tool called client-side routing. It's a little bit more complex, but that's the great illusion of that.
Well, thank you.
Yeah, it's a great question. So we're going to be using JavaScript in the browser to fetch data from a particular web page or source. We're going to do that using a technology called Ajax. If you think about this idea of, I want to get some data from somewhere else, we're going to be using GitHub. We're going to use the GitHub API because it's open, it's easy, and I'll show you how to make a request to the GitHub API, and it's relatively friendly to use. Why is that asynchronous? Why is this series of web technologies, why was it designed, why was it built internally to be asynchronous? Let's see if we can kind of stretch our brains a little bit of, when I go and get some data from GitHub, and I want to get information about my profile, why is that by nature asynchronous? Why is that not synchronous? When you go to a web page and you want to fetch some data, why do we think that was constructed to be asynchronous? Well, Banu, you're onto something, so we don't have to run the rest of the code. Sort of. Tell me a little bit more about what you mean by that. Just remember what happens when your code is blocked. If you go to GitHub and it takes 30 seconds to get some information back from GitHub, I don't know how fast it's going to be. I don't know how quick GitHub servers are. I don't know how great my internet connection is. I have no predictability of whether this is going to take 2 seconds or 2 minutes. If I'm on really great Wi-Fi at my house, it'll be fast. If I'm in the middle of the desert with a 2G connection, it's going to be really slow. Lots of really good things here. Sometimes the server needs a lot of time to get your requested results. We don't have to wait for a response to continue with our code, and that is excellent. While we are fetching some data, you might want to show the user a more pleasant user experience, like loading, or showing a loading spinner, or showing a user interface where things are slowly, progressively being loaded, instead of saying, I'm going to block, I'm going to force you to wait, and you can't do anything while you are waiting. So if it took a really, really long time to get that data, what if we want to show the user a nice progress bar, and maybe we can secretly increment that progress bar by 5%, but once we get a response back, we jump to 100%. So have you ever seen those kind of loading bars that are like 1, 2, 3, 4, 100? And you're like, oh my God, that's amazing. That's basically what they're doing. But the whole point is, it's really uncomfortable for the user, especially someone who doesn't know anything about JavaScript, when you block the thread, because they try to click around and they're like, oh, this is broken, I'm done. So Ajax, by its nature, was built to be asynchronous so that if you wanted to do something while you were fetching that data, if you wanted to tell the user loading ... or show them a fun quote or something to distract them while you're fetching that data, that's what we can do. And that's a very, very common user experience. When you go to a bunch of pages and you don't have your data right away, it will say loading ... or you'll see kind of an interface where maybe they like gray out some things until it's loaded. That's often called a skeleton, where you can kind of see this loading spinner here, right? It's not going to block the thread. It's going to show me that spinner and then show me how to manage my network. It's going to show me this and then finally load some data for me. Or when I scroll to the bottom, it's going to show me a really quick loading spinner. And then it's going to load that, a little spinner, and then it's going to load that. All right. I got to log out of LinkedIn because I waste too much time on that website. So let's go do that for my own mental health. All right. Man, what is all these pop-ups and everything? Okay. Let's talk about how to work with Ajax. Like we mentioned, pretty much everything you do in JavaScript is asynchronous. Everything you do in JavaScript is synchronous, with the exception of set timeout and Ajax. Set timeout is a good place to start, but you're not really going to build extremely large, sophisticated applications just using set timeout. Ajax is where things get a bit more interesting. In order to fetch data from an API, there is a built-in function to JavaScript in the browser called fetch. And if you spell it correctly, you will see that it is a built-in function in the browser. Fetch, as its first argument, accepts a URL to make a request to. So I'm going to go to https://api.github.com/users/le. How do I know that this is the exact path to go to? Because I looked at the documentation for GitHub and it told me to go to this plus whatever your GitHub username happens to be. This code by its nature is asynchronous. So if I go ahead and I say, here's my response, I'm going to console.log starting. I'm going to console.log response. And I'm going to console.log ending. I'm going to go ahead and log starting. I'm going to make a request to this API using Ajax. Fetch is a function that makes use of Ajax internally. I'm going to take a look at what the response is, and then I'm going to console.log ending. And here's where things get interesting. What I get back from the fetch function is something in JavaScript called a promise. A promise is a one-time guarantee of future value. Right now, I have no idea what that value is going to be. All that fetch has given me is a ticket that says, at some point, I'll get you something. I don't know when, but I guarantee in the future, I will give you a value. I don't know when I'm actually going to have something. If I look at response right now, yeah, I have a promise with a value. This is called a fulfilled promise. And inside of there, I have all that data from the API. Promises are a built-in construct in JavaScript for working with asynchronous code. When you fetch data using fetch or Ajax under the hood, you get back a promise. So the classic example of promises in action, but I'm going to assume, and there's no judgment here, that we have all eaten at a fast food restaurant at some point in our lives. So we'll go with McDonald's because it's a pretty common example. If I'm in line at McDonald's and Britt is in line behind me, and I go to the counter and I say, I want 12 Big Macs, it would be very unfortunate for Britt to have to stand in line and wait for my 12 Big Macs to come. So what do I get at McDonald's after I pay them for my 12 Big Macs? I get a ticket, and then I get out of line. And then Britt says, oh, I want a Diet Coke. Britt gets a ticket. Britt's ticket might be called before mine because it's probably faster to give someone a Diet Coke than 12 Big Macs. All that ticket is that I get back, that's a promise. That is simply a one-time guarantee of future value. We don't know when. I don't know when I'm going to get my Big Macs. I don't know when Britt's going to get her Diet Coke. But we've gotten out of line, and now Grace can go, and now Arjun can go, and now Jerry can go, and now Nathan can go, and now Brian can go. That is the idea of a promise. I'll give you back a ticket. I don't know when I'm going to have something, but I promise I'll get you something. There is a really nice tool in JavaScript that we can use where you can say, don't give me back a promise. Wait until I get that value back. So when you work with asynchronous code, you have two options. One option is to say, go ahead, make the request, give me a promise and go do something, and then I'll work with it. The other option that you have is to wait. Flash Ellie. I get back a promise. Let me make sure I actually spell GitHub correctly. When I go ahead, get back that data, I get back a promise. If I use the await keyword, I will go ahead and tell JavaScript to wait for this to finish running and then continue. So there's a really nice keyword in JavaScript. If you're dealing with something asynchronous and you want to wait to get something back, we can use the await keyword. So by default, its nature inherently with Ajax is to be asynchronous. But JavaScript gives us a really nice mechanism to say, hey, something asynchronous, I want to wait for it to finish, because I don't really want to show you anything until I have that data back. When you use fetch, it's a two-step process. The first is to get a response. The second is to convert your response into a data format that you can work with. I don't want to get too into the thick of it now, so I'll just tell you, after you fetch, just use this await response.json. And what you can see here is actually data that has come back from the GitHub API about me. Here's my bio, here's information about a blog, here's the company. I made this account in 2013. That's pretty nuts. Here's my URL, here's my name, here's the organization that I belong to. This is data that has come back from GitHub. And when I fetch that data, I have one of two options. One is to go ahead and fetch and get a promise back. The other is to wait for a response. And I can do that using the await keyword. The await keyword basically tells a promise to wait until you get something back. And this is very commonly how you fetch data asynchronously. If you go ahead and you want to, you can use this await keyword anywhere in JavaScript. This is a tool that is available to you as you start working with asynchronous code. This idea of the await keyword comes from a bunch of different languages, so it's not like JavaScript came up with this out of the box. So the two most common things that you can use in this case is fetch for asynchronous code and set timeout for asynchronous code. Set timeout uses a callback. Fetch relies on a promise. Callbacks are also a way to manage asynchronous code. It's a little bit of an older pattern. So promises and this await keyword are what you're going to see very, very commonly. If you want to use this await keyword, you can either use it on its own, or you can use it in a function. So I'm going to go ahead and make a function to get user from GitHub. And I'm going to pass in some username. And inside here, I'm going to go ahead and fetch some data. And this is an excellent question, Brian. I'll get to it. Brian asks, so does await kind of make it act synchronously, forcing you to wait? The answer is sort of. await doesn't just turn the asynchronous into synchronous. That would be too magical. That would be impossible. But what it does is just for that particular function, it will do that. So I'll show you exactly how this works in action. It's a really good question. I'm glad you asked it. For starters, it is illegal in JavaScript to use the await keyword in a function unless you use the async keyword for that function. So just a little bit of syntax for you to worry about. If you want to use await inside of a function, that function must be what's called an async function. What's an async function? A function that starts with the word async. A little bit more, but we'll keep it simple for now. I'm going to go ahead and I'm going to get some response from GitHub. So I will fetch HTTPS, and I'll go ahead and use a template string //api.github.com/users/whichever username I choose. So instead of going to Ellie every time, maybe I'll customize it so that you can go to whichever user you want. I'll go ahead and I'll turn that response into JSON. I can call this a parsed response. And I'm going to go ahead and return that data from my function. Actually, before I return that data, let's just console.log what my parsed response is, just to show you this in action. I'm going to console.log starting. I'm going to call get user from GitHub, and I'm going to pass in as my username, Ellie. And then I'm going to console.log ending. Console.log is synchronous. This function is what's called an async function. Inside of this async function, the code here will wait. The code here will wait. But outside of the async function, this is still asynchronous. So when Brian asked that question of, so does await kind of make it act synchronous only inside of this function? So when I look at the order of things, I'm going to see starting, then I'm going to see ending, and then I'm going to see my response. If I wanted to wait for this to finish, I could by doing this right here. The await keyword will pause for anything that is asynchronous wherever you use it. If you use it inside of the function, then outside, everything exists as is. If you use it here, it will block. Whether you want to block is totally up to you. Most of the time, you're really not going to want to block because that would be kind of difficult. But you can if you want. A couple questions here. Is Axios better than Fetch? Axios is a library that you can install that gives you the similar functionality to Fetch. Internally, it uses the same things that Fetch uses. But it's a library that has its own API, and you have to kind of learn how to work with it. It's totally fine. Fetch is built into the browser, so just a little bit to use out of the box without having to worry about installing other things. But Axios is absolutely a fair alternative to using Fetch. I just didn't want to have to muddle us with other libraries and other APIs and so on. Peter asks, any other functions that you may nest in get user from GitHub, do they become async as well? If you call a function that's an async function, unless you await it, it functions as normal. If you define new functions inside of here, they're either async or not. You have to choose. So nothing is like naturally turned into asynchronous inside. You got to do that all on your own. You got to be explicit. If you're using await on Fetch, why do you need to use await on response.json? That's the way that Fetch works internally, because there's still a little bit of time that it takes to take this response and turn it into JSON. So if you don't have the await keyword here, you're still going to get a promise back. That's just the way that fetch works internally. That's its mechanism for parsing that. So that operation itself is internally asynchronous as well. These are really good questions here. It's a really strange concept, but the best part of it is you can go to the Chrome console and just start messing around with it. So instead of worrying about building a whole interface and so on, you can play around with any API. You can Google for GitHub API or free, open, easy API, and you will get, here's the place to go to. GitHub's a friendly one because it's a pretty easy place to just get information about a user, their repositories, or so on. And it's a really good place to play around with asynchronous code. Ajax is something that is used extensively in real-world applications. So you're going to see Ajax pretty much everywhere. If you ever want to see that for yourself, you can go to a website. Let's go to Google Maps. I'm going to open up the network tab. And I am going to go click on where it says fetch/XHR. And this is going to show me all of the requests that are being made. Each one of these things that I see, these are all requests that are being made via Ajax. Google Maps uses a lot of Ajax. In the applications you build, you probably will not be making 232 requests just when I look for Rithm School on a map. But if you ever want to see, hey, is a website using Ajax, you can always go to the network tab. You can click on this fetch XHR that will show you just the requests that are using Ajax. XHR is the older way to make Ajax requests. Fetch is the newer way to make Ajax requests. They are essentially doing the same thing under the hood, but fetch is a much nicer way to do it. And each of these are their own individual Ajax request. So if you wonder, hey, is the website actually using Ajax? Go to the network tab. It's opening up the Chrome console, click on the network tab, go to fetch XHR, and you will see all those requests that are being made. As you get more comfortable with web development, as you start working with APIs, this tool is a godsend. This is an amazing source of truth for what's happening as I make requests and see information being passed around. The last piece I want to talk about is a little bit more on the internals of how this stuff actually works. But I want to pause for any questions before. This 200 status basically means that everything is okay. This 204 status, you can kind of see here, 204 basically means that everything is good, but nothing's been modified. So 204 is very commonly a status code you get when something is cached, something is stored, or it's already remembered in some place. Any status code in the 200s is a sign that all is good. As we see, there are some things were canceled. Maybe we made that request and then realized we didn't want to make it. If there were any errors, you would see things in the 400s, like 404s. Any errors on the server, you would see things in the 500s. But turns out Google Maps is functioning and doing what we wanted to do right now. So all is good over here. The best thing to do is play around with these methods. Tanya is linking to status codes and cats. Absolutely. There's a status cats, which is a wonderful website if you want to look at status codes. There's also status dogs. If you're more a dog person, then you can look at all those status codes, kind of see what those numbers mean. What happens if the fetch request never gets data? How do you cancel the request? Is that code or is there a construct to use in JavaScript? Yes, there's a construct in JavaScript that you can use to cancel a pending request. It's called an abort controller, and it's a little bit beyond the scope of what we're doing now, but yes, it can absolutely be done. That's code that you can use in the browser natively. When you use libraries like Axios and so on, they give you really nice abstractions on top of that. They just give you, oh, here's a function called cancel. It'll do what you want. Under the hood, it uses these kind of built-in tools that we have. But yes, you absolutely can cancel requests. That's super important when you're at really, really high scale. If someone navigates to a different page and you're fetching some things that you don't need anymore, well, cancel that. Don't make the server do work. Don't make the database do work that it doesn't need to do. And that's super important for performance when you're at a much larger scale. The last piece I want to talk about is how is this actually working under the hood? We've seen that asynchronous code is code that does not necessarily run line by line. But how is this actually working under the hood? Internally, there is a mechanism called the event loop. This is something that is built into the JavaScript language. And the event loop consists of 3 important parts: stack, the heap, and the queue. If you've learned lower level programming languages, these ideas should be very familiar, especially the stack and the heap if you've worked with memory or in lower level environments. So I will give you the very, very high level analogy in JavaScript. The stack is where function invocations are stored. When a function call happens, when you invoke a function like console.log, it is placed on the stack. The stack is a special data structure, which is kind of like a stack of pancakes or a stack of building blocks. If you are given a stack of pancakes, the first pancake you're going to eat is the one at the top. The last one that has come in is the first one in your belly. Stack is what's called a last in, first out, or LIFO data structure. The heap is where your variables live. You can think of the heap as just a giant truck that just stores all your variables. Is the stack AKA execution context? No, those are 2 different things. The stack is where all of your function calls live. Each time that a function is called, something called an execution context is created. So for every function called, it gets its own execution context. That's a very fancy way of just saying all the stuff that function is doing, it lives in one place called the execution context. The queue. The queue is where async stuff goes. This is where things get interesting. When I console.log, hello, this function goes on the stack. It executes, and once it finishes executing, it is removed or popped off the stack. This is how it works with synchronous functions. You have a function to add 2 numbers. When the function has finished running, or when JavaScript sees the return keyword, boom, off the stack, it's done. So if you ever wonder, what does the return keyword do? It gives me some output, yes, but theoretically, it takes the function off the stack. Once you return, JavaScript basically says, my work with that function is done. On to the next one. When you do something asynchronous, it's a little bit different. The first thing in this code that goes on the stack is console.log. It finishes executing and it pops off the stack. The second function that goes on the stack is set timeout. And set timeout is a built-in function in JavaScript that does something very, very nice for us. Rick asked the question, is it possible to view the stack or the heap or the queue? You can't really view the queue, but you can absolutely view the stack and the heap. So I'll go ahead and show you what that looks like. I'm going to set a breakpoint on each of these lines of code. And here we can see the call stack. Unfortunately, you can't really see the queue because it's an internal data structure that's managed, so you don't really get an easy way to access it. But in the Chrome DevTools, we can see the call stack. This anonymous is essentially everything that's powering all this code. So I want you to ignore that one. I'm going to go to the next line, and I'm going to call console.log. Console.log is going to run and immediately pop off the call stack. Set timeout is going to run. And set timeout is also going to immediately pop off on the call stack. If I go to the next breakpoint, I will actually see that set timeout is not there anymore. What this function does internally is it notifies the event loop. It notifies the internal data structure in JavaScript called the queue. And it says, in 2000 milliseconds, queue up this function to be run. We don't keep adding things to the call stack because we want our code to continue executing. We don't want to block. We don't want to keep the call stack just waiting. So we go to console.log and we see bye. And then 2 seconds later, we see from this set timeout that we have a console.log of hi. So under the hood, we are instructing to the queue, and we are telling JavaScript internally, in 2000 milliseconds, go ahead and run this function for me. That is the internal mechanism that powers what's going on here. This leads to some pretty interesting behavior, because now I'm going to set this to 0. I'm going to console.log starting. I'm going to console.log all done. And I'm going to console.log ending. So I'm going to keep this on one line to keep it simple. Even though this looks like it will run immediately, it doesn't. Because what happens is console.log of starting runs, goes off the stack. Set timeout runs right away, and it tells the queue, hey, in 0 milliseconds, go and run this function. But in JavaScript, the queue cannot run. The queue cannot get processed until the stack is completely empty. So while we are sending something to the queue, even though it looks like 0 milliseconds, it's actually not. And that's why this is never a guarantee that it's going to be done in 0 milliseconds, because this code only runs when the call stack is empty. In fact, if I went absolutely insane here, and I printed this out 10 times, or whatever that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, nice, 10 times. I'm going to see starting and then ending, because the queue cannot move. The queue cannot process. People often call this a tick of the event loop. The queue cannot continue until the stack is empty. So internally, what is the data structure that powers this whole thing? If you're curious, if you want to learn more about it, it's called the event loop. The event loop consists of a stack, a heap, and a queue. The stack is where your function calls go. I'll show you one little example where you can see the stack in a bit more action. I'll make a function A, which calls a function B. I'll make a function B where I'm going to pause in the middle that calls a function C. And I'll make a function C. And inside of C, I'll just put a debugger. When I call A is on the call stack. A goes to the next line and it calls B. Once B is called, B gets put on the call stack. A cannot finish executing until B has finished executing. This is how the stack works. We're kind of stacking up some pancakes here. What happens in B? B invokes C, which gets us to this debugger. And here's what the call stack looks like. When C finishes running, we're going to go back where we left off in B, which was this line right here. B finishes running, so it pops off the call stack and it goes back to where A was. Where did A leave off? Right here. There's nothing left for A to do. And the next breakpoint is all done. I finished running all of my code. This is where you can see the call stack in a bit more detail. Couple questions here. When I use set timeout in React, looping is processed. Why does it happen? I'm not totally sure what you mean by looping. You might mean like if it's re-rendering or something. If you're doing a set state inside of your set timeout, then you will re-render and you will start another timeout. So that could be where that's coming from. Is the queue independent for the set function for set timeout, or is it shared with other functions? It's one singular data structure. So if you have 5 set timeouts, they're all getting queued up in one single queue. So it's not shared. It's not an individual queue per function. Where are closures stored if the execution context is pop off the stack when it's accessed? With the case of closures, JavaScript is very, very smart. JavaScript keeps an internal pointer to an execution context, even though that function has returned. That's what closure is. Closure is the phenomena, the magic, the ability for functions inside of functions to remember stuff from the outer functions that have closed over them long after they've returned. How is that done? That's done internally through memory management, through the use of closure. Tanya asks, so it's like parentheses inside of parentheses inside of parentheses in math. Yeah, it's very much, and I don't want to get too mathematical here, but I have a function f calls g calls x, f of g of x. That is, yeah, if you're coming from any background there, that is exactly the idea. With the case of closures, I'll repeat that again. We do have a workshop on closures. So if I tell you all of this now, you're not going to show up. So maybe Britt is raising her hand to stop me from talking about closures for an hour. Thank you, Britt. But the phenomena, the magic of closure is the ability for a function that returns. Because we just said when a function returns, JavaScript is done. JavaScript forgets about it. Closure is the magical ability for functions that return functions to not totally be forgotten and to still have some kind of remembrance. But I'll leave you with that nugget for the next time because that'll make it more exciting for you to come back. All right. Async's a tough concept. There's a lot that you can do. Last question, can you ever access or dereference a pointer like C++? No, not at all. You don't have control over direct memory management like you would with a language like C++ at all. That is completely abstracted by a virtual machine and a garbage collector. So you can't go to a lower level of memory management like you can with C or C++ or languages in that sphere, I would say. All right, async stuff is a lot. Most important thing to do, play around with set timeout. Look at the documentation for fetch. Build some small applications yourself. Futz around, play around. You can always take a look at content or curriculum that we have. Feel free to reach out to us with questions. Thank you all so much for giving me an hour of your time. Hope it was informative. I know this is a tough concept. Just want to say thank you so much again, because it's a long hour and making it through a Zoom bomb takes a lot of courage. So thank you all for doing that. And oh, what a wonderful world we live in these days. So thank you all for being respectful and mature and polite for the most of you. Hope to see you on a very future Zoom session soon. And as always, be in touch with us. If you're interested in our bootcamp, do reach out with questions. We'd love to hear more from you. Hope to see many of your faces on Zoom real soon. And thank you all so much and have a wonderful, wonderful day.